Section 1.3, Complex Numbers, Part 2. The standard form of a complex number. This is the standard form of a complex number, where A represents the real part and the BI represents the non-real part. So when we have a complex number in standard form, any real part comes first. Then added to that is the non-real part. In the A plus BI form, when B is equal to 0, we have a pure real number. Notice that we would have plus 0, so it would only be A, and A is the real part. When A is equal to 0, then we have a pure imaginary number. If A is 0, then we would just show the BI part, such as 2i or something like that. So we have pure reals that don't have an I in them at all, or pure imaginaries that only have an I in them with possibly a coefficient or a coefficient of 1 if we just see I. So we need to learn how to perform operations with complex numbers. Let's look at how we would add or subtract complex numbers. Our example is subtraction. Now just let your intuition take over. What do you think we're going to do with this problem? If you can think about that right now and not just watch me do this, then you'll know whether or not this is just coming natural to you. And I think it can if you'll just look at it. So obviously, the first thing I've got to do is remove parentheses. Okay, parentheses are gone. Now I want to combine things that are like the 7 and the 3, the 2i, and the negative 4i. So we have the 7 minus 3 plus, I'm just going to put a plus between because remember it's A plus BI, so I'm just going to get ready for that. 2i minus 4i. So what do we get here? We get 4 plus, and in here, negative 2i, which more simply we would write as 4 minus 2i. 4 is in the real number part, and negative 2i is in the imaginary part of the complex number. So adding and subtracting are simple. Adding's even easier, right? Subtracting, we do have to distribute the negative. What about multiplication? Again, let your intuition take over here for a second. What do you think you want to do when you see something like this? If you're thinking FOIL, that's a good answer. So let's try that. We're going to multiply. First times first. 3 times 4 is 12. Outside times outside. We have 2i times 3, so that would be plus 6i. Inside times inside. Negative 6i times 4 minus 24, 24i. And then last times last, well, it's a negative times a positive. That will be a negative. 6 times 2 is 12. And then we have an I in both terms, so that's going to be I squared. Okay, not done yet. We needed an A plus BI form. Okay, so let's see what we have here. We have 12, and then this plus 6i minus 24i. What does that give us? Minus what? 18i, and then minus 12, and what about I squared? Remember, I squared is negative 1. You will never have an answer with an I squared in it. That's not simplified. So we'll plug in negative 1. So we have negative 12 minus 18i and negative 12 times negative 1, positive 12. So finally, still not done. This is not an A plus BI form. I have two real parts here. So I need to add those together. 24 minus 18i. Okay? Let's talk about something called the conjugate of a complex number. So if the complex number is a plus bi, we write the conjugate as a plus bi with a line over it to mean the conjugate, and what that's equivalent to is a minus bi. Likewise, if our complex number is a minus bi, then we write the conjugate of that with a minus bi with a line over it, or a plus bi. So what if we multiply a complex number by its conjugate? What would be the conjugate of this complex number? Right. So let's multiply these. And we already looked at multiplying, that we would use the FOIL method, right? So first times first, 2 times 2 is 4, outside times outside, inside times inside, and last times last. That'll be negative because it's a negative times a positive. 5 times 5 is 25, and I times I is I squared. So what happened here? Well, this middle term cancels, doesn't it? And we have 4 minus 25 times negative 1, or 4 plus 25, which of course is 29. But notice what we got here. This was the a, wasn't this a squared? 2 squared, so there's a squared, that's where we get the 4. And where'd the 25 come from? Well, isn't that b squared? So in other words, when we multiply a complex number by its conjugate, this is the standard form of the result.